Welcome to this second part on economic evaluation. In the previous lecture, we discussed how to calculate fixed costs through the total capital investment and depreciation. Now we can calculate the variable cost as the sum of the feedstocks, utilities, labor, and maintenance. For feedstocks and utilities, all raw materials, consumables, and energy sources used in the process should be accounted for, including substrates, nutrients, solvents, heat, and power. The materials and energy flows are available from the mass and energy balances. Prices for materials are often available to the process design team. However, they could also be retrieved from databases for chemical commodities like the Independent Commodity Intelligence Service, ICIS, or directly from suppliers or from scientific or technical reports on techno-economic evaluations. Market analysis for specific products is an option too, but they usually have a paywall. In the case of utility prices, those are location specific, and the design team should have access to local prices for electricity, natural gas, and water. As discussed in the previous lecture, prices might be available for previous years, but our data and calculations should be on the same time point for a consistent economic analysis. Outdated prices can be corrected to current levels by using the producer price index. You can check those websites in the slide for price corrections by countries or for specific chemical commodities. Maintenance costs can be a straightforward estimation. It is commonly accepted to use 5% of the total depreciable capital. For the annual labor cost, we need to estimate the number of operators per process unit, which depends on the type of materials handled in the process, the operation mode, and the production scale. For the annual wages, 5 shifts are normally considered per position to account for rotations and time off, and a 50% extra is applied to consider other personnel. We can now calculate the total production cost, which are highly dependent on the total per purchase equipment cost. An important point for reliable cost estimations is the data consistency in terms of production scale, time point, and location. And we can now calculate the annualized total production cost. They can also be reported per unit of main product, which is convenient for communication and comparative analysis. Let's discuss now some of the financial indicators that are widely used on process economics. The payback period is a very simple, understandable, and informative indicator that gives a direct idea about the economic feasibility of the project. This refers to the time in years required to recover the total depreciable capital investment, and an acceptable payback period for investors in the industrial biotechnology sector would be below 7 years. Another important economic KPI is the return on investment. This refers to the annual interest rate made on the total original investment. Please notice the difference between the total depreciable capital used for the payback period. The cash flow analysis is also used to better understand the dynamics between earnings and expenditures on an annual basis. Let's check this in a cash flow chart. The first couple of years of the project are mostly investments on design and engineering, construction, and startup. At this point, we have the maximum investment, including the working capital, to start up the process. Then, once production starts and reaches the expected scale, there is a steady flow of income and margin that accumulates over time, reaching first the break-even point and then continues to accumulate for the rest of the project lifetime to finally reach the total cumulative cash flow. The annual cash flow is also used to calculate the net present value of the project, which accounts for the sum of the future annual cash flows adjusted to present values. To make this adjustment, we need to understand how the monetary value of a present investment would have a different monetary value in the future due to the compound effect of the interest rate over time. Likewise, future cash flows can be represented as present monetary values. In this way, we can calculate the net present value of our project based on the annual cash flows. The techno-economic evaluation described so far is for a static condition on the different process variables. We have considered, for example, a given process scale, fermentation yield, stoichiometry, and process efficiencies in the downstream units. But as process designers, we are often challenged to understand what would be the technical and economic performance of the process if we consider other values for some key parameters and some variables. For this reason, we should complement our process design with sensitivity studies. Let's take a look, for example, at the composition of the total production cost. Fixed costs depend only on equipment costs, which we can refer as to technical data, and variable costs are calculated mainly from the mass and energy flows, which are technical data too, and from the prices of raw materials and utilities, which are economic data. Then, from the combination of this technical and economic data, we can calculate the different financial KPIs. In this way, we can apply similar techno-economic evaluations for different processing conditions and economic parameters to better understand how the process performs when certain variables and parameters are changed within a given range or for some limit values, like, for example, the maximum theoretical reaction yield or 100% efficiency in a downstream process unit. This distinction between technical and economic data is important since the results of the sensitivity analysis can help us to identify what functions should be prioritized for further technological research and development. For example, it could be better to focus on improving the volumetric productivity of a fermentation system rather than developing a fermenting strain that is more resistant to higher product titers. Finally, this analysis can show us the sensitivity of the indicators of interest, which could be technical or financial with respect to the process variables and economic parameters. And these results could be visualized in absolute or relative values. This is all by now, and thank you for your attention. See you in the next lecture.